In the previous class, we learned what is the rank of a matrix, and we saw that it plays an important role in understanding the matrix decomposition. At least there was a rank decomposition, which helps us in computing the different examples of a square is a and things like that. All right, how do we construct examples? Let's proceed further and try to understand it using system of linear equations. All right, so now we are looking at the system of linear equations. So there are two things. So we are starting with the system ax is equal to b, where a is the coefficient matrix aij m cross n, coefficient matrix. X is supposed to be x1 x2 xn, n cross 1, a vector of unknowns, and b is supposed to be b1 to bm. It is an m cross 1 vector, and generally we are taking it in terms of real numbers or complex numbers. All the entries are in that part itself. All right, fine. So what we have learned is, one of the important thing was that if I want to look at the RREF of AB, the augmented matrix, if I look at this, then this contains RREF of A, because A is supposed to consist of the first n columns of this matrix. All right. So if the RREF of this matrix is supposed to be CD, where D is a vector of m cross 1, and this is of size m cross n, then this will imply that RREF will be equal to C itself. All right, fine. So it is there itself. So the number of pivots, therefore, the number of pivots in CD, and in C can differ by at most 1. Fine, because one extra column is being added, that's also it has to be the same. Fine, because RREF is supposed to be sitting inside that part. Fine, C is there. So therefore rank of AB, this matrix, minus rank of A, the coefficient matrix, this difference is either 0 or 1. Fine. So we look at the first case when the difference is 1, and when the rank is not 1. So case 1, the rank of AB is equal to rank of A plus 1. This implies there is a pivot in the n plus 1th column. All right. Number of pivots we do not know. All right, but we know that there is a pivot in the n plus 1th column because the rank increases by 1. Fine. So this implies, so look at this. So this implies the pivotal row has the form 0, 0, 0, and 1. Why? Basically because what is a pivot? Pivot is the first non-zero entry. All right. Since it is the first non-zero entry, has to be in the n plus 1th column. All right. The first non-zero entry, the pivot, bracket made the first non-zero entry, has to be in the n plus 1th column. Fine. And this equation, therefore this corresponds to the system 0 times x1 plus 0 times x2 plus 0 times xn is 1, which has no solution. So therefore we have things that we need to understand. Question: when can a pivot exist in the n+1 column? Well, this is the question that one needs to understand. So we cannot answer it fully now, but at least some things we can say here. For example, we can say that the b vector has to be non-zero. At least the b vector, so at least the vector b is a non-zero vector. All right, fine. So 0 is the size m×1. It has to be a vector which is different from 0, because if there is 0, then whatever operations I use, row operations, I cannot make that as a non-zero vector. All right. So therefore what we are saying here is, therefore what we are saying is that if b is not equal to 0 and rank of augmented matrix is greater than rank of the coefficient matrix, then the system ax is equal to b has no solution. Right? I also want you to understand that if b is 0, then rank of AB has to be equal to rank of A, because there are no extra columns to consider, because everything is 0 there. All right, so I cannot get anything pivot there in that part. Then rank of this equal to this, and we always have a solution, namely x0 is equal to 0 as a solution of ax equal to 0. Fine. Why is 0 here? Because b is taken to be 0 here. Fine. So now let's look at different examples to understand the solution here, slowly and build up the idea. Fine. So example. So now we have looked at the case that rank of AB is equal to rank of A+1. Now we are in the case when rank of A is equal to rank of the augmented matrix. All right. So now we are looking at the example where the rank of the augmented matrix is equal to rank of the coefficient matrix. Fine. So let's proceed with that part. So let's take an example to understand it better. So suppose RREF of AB has this form: 1 0 0 2 0 0 0 1 0 minus 1 2 0 and 2 3 0. Suppose this is the form of RREF of this. All right. From here we want to look at the solution space. Fine. So I would like you to see here that this implies that the first equation corresponds to x1 plus 2y1 2x2 minus x4 is equal to 2, and the second equation corresponds to x3 plus 2x4 is equal to 3. Fine. So what we have is, we have this two things which are the pivot. This is a pivot, this is a pivot. Fine. These are the two pivots that I have, pivotal columns. So this corresponds to the variable x1, this corresponds to the variable x3. So we call them as basic variables. All right. This is very important. The columns corresponding to the variables corresponding to the pivotal columns are called basic variables. All right. So here what I can do is that I can rewrite this as x1 is equal to 2 minus 2x2 plus x4, and here I can write x3 as 3 minus 2x4. So we are writing the basic variables. X1 and x3 are the basic variables. We are writing them in terms of what are called non-basic variables or the free variables. So here x1 and x3 are basic variables, correspond to pivotal columns. Fine. Basic variables, and x2 and x4 are free oblique non-basic variables. All right. Further, the basic variables can be written in terms of constants and free variables. So this is very, very important that you can always do it. And not only do it, this is important to observe here that also observe that look at this is a free variable, sorry, this is a basic variable. And since this has appeared before this, all right, so this has appeared before this variable, all right. So when I write x3, x2 does not come. So when I write x3, I can get only x4, x5 and something which is later, not before. Similarly, x1 is there, so x1 can contain x2, x4 both, but it will not contain any basic variable, all right? Because these entries are all zero, so basic variable when I write, any basic variable will be in terms of constant and free variables. The basic variable will not create trouble for us, all right? So this is very important that we are able to differentiate between things, fine? So keep track of that. So what we are saying here is that if I write x, which is supposed to consist of x1, x2, x3, and x4, then I can write x1 in terms of constant, which is 2 minus 2x2 plus x4. x2 is a free variable, so we leave x2 as it is. x3 can be written in terms of 3 minus 2x4, and x4 is again a free variable, so we write x4 as it is. Fine. We can break this vector in terms of, look at here, 2 0 3 0, the constants, plus something which comes out from the x2 part. x2 is going to come from minus 2 here and 1 here, 0 here, 0 here. And look at x4. The important thing about x4 is that x4 can come at any place, but there is a 0 here as far as x4 is concerned, minus 2 and 1. Fine. So what I want you to keep track here is that look at here, there is a 0 here. Look at here, there is a 0 here. So if I look at this part, look at second and fourth entries in x2 and x4 in the vector corresponding in the vector for x2 and x4. What I get is I get 1 0 here and 0 1 here. Well, so this is a very important idea. All right, they lead to something nice at some stage. All right, so look at here is 1 0 0 1. So they are basically giving me I2 1 0 0 1. All right, fine. So the idea in pivots also we wanted IR sitting inside. Here also you can see that in some sense some sort of identity is coming. There are two free variables, so there is I2 here. Fine, that's important for us. Fine. Now something more. So I have this for me. So I want you to understand what are these three vectors. All right. So let us go back to our original matrix that we had. Our matrix was 1 0 0 2 0 0 0 1 0 minus 1 2 0. So this was our RREF of the coefficient matrix. All right, this is what it was. Fine. So on this I want to multiply by this vector 2 0 3 0. What do I get? Fine. So this by matrix multiplication. All right, so this part is only this and then multiplying here. So if you look at here, what we are saying here is that multiply 2 to the first one, 0 to the second one, 3 to this one. All right, so 2 times the first column is 2 here. Fine. So what I'm looking at 2 0 0 plus 0 times the second one, so 0 times 2 0 0 plus 3 times 0 1 0 plus 0 times the fourth one is minus 2 0, and therefore I get it as, just look at it, 2 3 0 which is nothing but the this part is the RHS of RREF of AB, right? Therefore, this vector 2030 is a particular solution. So remember, any solution of the system Ax is equal to B is of two types, has two parts. One is the particular solution and the other is the solution of the homogeneous part. So we have got the particular solution. Let's now try to get the solution of the homogeneous part. And here these two vectors are going to play the role, -2 and this two are going to play the role. So let's do that also. So our matrix is 1 0 0 2 0 0 0 1 0 -1 2 0. Let's multiply this with -2. What did I get? -2 1 0 0 -2 1 0 0. So this part tells me that it is -2 times the first one plus 1 times the second one, and the rest are 0. So therefore I get it as 0 0 0. You can verify that this is 0 0 0. Similarly, 1 0 0 2 0 0 0 1 0 -1 2 0. This times the next vector, which was 1 0 -2 1 1 0 -2 1. All right, this is same as, let's multiply it out. 1 times the first column, 0 times second is not an important thing, -2 times the second one, 0 1 0, plus 1 times this, so -1 2 0. You can see that this is 0 0 0. All right, fine. So therefore what I see is that, therefore the vectors associated with the free variables x2 and x4, namely -2 1 0 0, this transpose, and 1 0 -2 1 transpose, namely this and this, are solutions of the homogeneous system Ax is equal to 0. All right, fine. So from the system Ax equal to B, we go to the RREF, and from there we have conclude these things. All right, so this is very important that such conclusions can be made. All right, fine. So as a summary of whatever we have done now, I'll just state the theorem. For the proof, you need to go and understand it slightly better. It takes time, so I'll just write it. You understand it at your leisure. All right, let Ax is equal to B be a linear system where A is of size m cross n, x is n cross 1, and consists of the n unknowns, and B is m cross 1 and is the right hand side of the system Ax is equal to B. All right, fine. Also let us assume, let RREF of AB is equal to CD. Suppose it has this form, and in this language I want to write everything. All right, so let me write that. So 1, the system Ax is equal to B is inconsistent, there is no solution. System has no solution, is inconsistent, has no solution if rank of the augmented matrix is strictly greater than the rank of A, the coefficient matrix. All right, and this can happen, possible to happen only when B is non-zero. All right, fine. 2. The system Ax is equal to B is consistent if rank of this is equal to rank of A. Fine. And if it is consistent, now the question arises whether do we have a finite number of solutions or we have infinite number of solutions. So further, so the important thing is that I have consistency. That is more important because I don't have pivots on the right hand side. So this is important. Further, A, if rank of A is equal to M, which is same as the number of unknowns, then the system Ax is equal to B has a unique solution. Why unique solution? Basically because I'm saying that the rank of A is n, so there are n pivots. It means that each column contains a pivot, so each column corresponds to a basic variable. So you don't have any free variables, you have only the basic variables. All right, so when you want to express basic variables in terms of free variables, there are no free variables, so everything is a unique solution. Fine. B, if rank of A is k, which is less than n, fine, then Ax is equal to B has infinite number of solutions. Why they have infinite number of solutions? Basically because, so this implies, or this part implies that there are n minus k greater than 0 greater than equal to 1 free variables. All right, and free variables means these free variables will lead you to, so I'll just write the form that I have in this case. So in this case there exist vectors x0 u1 to u of n minus k. So look at, there are n minus k of them because n minus k are free variables, n minus k, with a of x0 is b. So x0 is your particular solution. Fine. And a of ui is 0 for 1 less than equal to I less than equal to n minus k. Fine. And you can see that again, since you're looking at these free variables, so if my free variable is there, then you will get I of n minus k sitting inside this. Also if I write u1 u2 un minus k in the order in which the free variables appear, then this will have I sub n minus k inside it. All right, so this is what you have to be careful about, that there is some matrix in minus k sitting inside it. Fine. So that's all in this lecture. I would like you to understand it nicely because these are very, very important. So what I would like to say is that, for example, if I know that I have a free variable x2, x5 and x6 are there, fine. So x2, if I want to write here, for example, so I'll have x2 somewhere, x5 somewhere, x6 somewhere, and there will be other entries also. I don't know what they are. So if I take out x2 common, x2 is not going to appear below because I can write x1 only in terms of x2, x3 or x4 can be written only in terms of x5, x6 and so on. Fine. So I cannot write x3 in terms of x2. This is what I said, because the pivot comes afterwards. All right. Fine. So x2 will have something here. I don't know what it is, but there will be one here. The zeros will be here somewhere. So this corresponds to the fifth entry. This corresponds to the sixth entry. So there are some things here. Fine. Similarly, I will have plus, I don't know what it is, but some x5 will come. So it will be 0 all the way, and 1 will be there, and then 0 is here. This one is the fifth place. And similarly for x6, and therefore I'll get at least I3 here. Fine, things like that. So that's all. Please sit down and then write out or look at my notes. That will make you clear. All right. So that's all. Thank you.